Welcome to the 2024 Sargan lecture. I've been asked to remind you of the code of conduct, which if all is well you've seen many times already. The key message is that you should be a good person and a good economist throughout, so please behave. The Sargan lecture commemorates the fundamental contributions to and profound influence on econometrics by John Dennis Sargan. It does so by promoting econometric theory and methods with substantive, direct or potential value in applications and their actual empirical application. The Econometrics Journal has always been involved with the Sargan lecture and has been publishing it since 2019. I'm the managing editor of the Econometrics Journal, and I'm happy to report that we have now published or close to publishing Jim Heckman's 2019 lecture, Guido Imben's 2021 lecture, Serena Ing's 2022 lecture. We're also currently processing Frank Diebold's lecture from last year, and I guess this brings us to today's lecture. I'm delighted that another great economist, Maria Cristina Denardi, has accepted to deliver this year's Sargan lecture. Maria Cristina embarked on her academic career in beautiful Venice, so I learned, and got a PhD in Chicago, which is nice in its own ways. After that, besides a spell at University College London, she stayed true to the American Midwest. She worked at the Federal Reserve Banks of Chicago and Minneapolis, and is currently the Thomas Sargent Professor at the University of Minnesota. Maria Cristina was elected a Fellow of the Econometric Society and honored in many other ways, and I would say rightly so. She has an impressive body of work on the dynamics of and inequality in earnings, savings, wealth, and health, in relation to macroeconomic conditions and taxation and other policies. Her research is always inspired by important socioeconomic facts and puzzles. It masterly employs dynamic economic modeling, computational methods, structural econometrics, and empirical analysis in various combinations, as we will see today, to make sense of these facts and puzzles. So, without further ado, let me say it's a pleasure and honor to have Maria Cristina Denardi deliver the 2024 Sargan lecture. Before she starts, one household message. So, Maria Cristina is more than willing to answer small clarifying questions, and we will do our best to see them if you have them, but if the real discussion should be kept to the end. So we'll leave time at the end for the discussion, okay? So Maria Cristina, thanks a lot for coming, and the floor is yours.
Thank you very much. Thank you very much for this nice and generous introduction, Jaap, and thank you for the honor of being here. Of course, I'm following huge steps, and so it's a bit stressful. And also, I have never given this talk before, but I did work very hard, so I hope that I will tell you something that you didn't know before and that you will find interesting. So this is about health inequality and health types, and it's joint work with Margherita Borella, who is at the University of Torino, Francisco Bullano, who is a PhD student at Minnesota, Benjamin Kruger, not Dirk Kruger, Benjamin Kruger, who is a PhD student at Northwestern, and Elena Marresa, who is a faculty at NYU. And the usual disclaimer applies. So I was at the health session this morning, great papers, and I learned a lot, so perhaps I don't need to convince many of you that health is a crucial aspect that affects many economic decisions, and many economic decisions that most of us study repeatedly. So this is a short list, but you can think of many other outcomes that health affects. For instance, you are not in good health, and it's harder to go to work, so it affects your labor supply, it affects your wages, and therefore your earnings through both wages and participation or hours, and retirement, because you might have to retire earlier or later, depending on your health. Obviously, it also affects medical expenses, and depending on the country you are in, you might have to pay for out-of-pocket for at least some, if not most, of those medical expenses. obviously, health also affects your life expectancy, and through all of this, also your savings. So, the point is, I think it's very important that we understand better health and its dynamics, and that's my goal today. This is just a very partial literature review on a very partial set of outcomes related to health. So we are writing the paper. Please don't be shy and send me papers or references, because it's a big literature and we would like to make sure that we don't miss. An important paper is by Eric French, which was one of the, to my knowledge, an important contribution studying the role of health in labor supply and retirement, all the way to more recent contributions like the one by Monica and co-authors. And there is just a lot of evidence that health is super important for these outcomes. So what are our broader goals? Well, this previous literature has taken a stand on what health is, how we should measure it, and how we should model it, and has looked at the consequences of health depending on these assumptions. So I would like to go back to this building block of understanding health and better understand during both middle and old age, because this is the strength of the data set that I'm going to use, how health and mortality evolve, and how unequal is the evolution in health, and how to better model it. And hopefully, by the end of the talk, I will convince you that there is something that right now is nebulous, but people belong to different health types, and obviously, hopefully, this will come much clearer as we go along, and that it is important to explicitly model these health types, and down the line also understand how these health types are formed earlier on. That's also a very crucial question. But first, it's good to document, are these health types there, and what do they do, right? This is a first step into a long investigation by me and many others. So from this, there will be a lot of moving pieces in this talk. So I thought that to help people keep track of what is going on, it's easier to break them in smaller questions and to provide an answer to that smaller question to build to the bigger picture. Because when I was going through the pieces of my presentation, I thought, how are people possibly going to keep track of all of this? So question one is, are there health types in adulthood? And here you start having a little more information. What we think of a health type is a health trajectory, or it's something that characterizes person's health and gets expressed in the health history that the person has, okay? The second question is, well, can we find these health types? And I will be clear on telling you how we achieve that. And then what are they, okay? And the third question is, well, okay, so this is going to be a non-parametric, very flexible method. It's not going to take a stand about whether these types are related to observed heterogeneity or unobserved heterogeneity, but an important question is this something that is captured by observables, and therefore previous work is already indirectly taken into account because they condition on a lot of observables, or is it mostly unobserved heterogeneity, in which case we really need to think more about these health types. The fourth question is, okay, so we have these health types, and I can already tell you it's mostly going to be unobserved heterogeneity. What do we miss if we don't model these health types? How important are they? Some people have blue eyes, some people have green eyes. Well, maybe that's not super important for understanding the consequences of policy. So then the last question I want to answer in the more specific question is, well, given what we have learned, what is the most parsimonious way of modeling these richer health dynamics? One of the goals is, if we want to put this in a structural model, do we need to model all of the observed heterogeneity? We know that women tend to live longer. We know that more educated people tend to live longer. We know that married people tend to live longer. Do we need to keep track of all of this? Or maybe it's all summarized into a health type once people are already middle-aged. Okay? So let's go back to the first question, and then let me say what we do to answer it, and then I will give you the answer to the first question, and then we will move on. Are there health types in adulthood? That is, do people have different health experiences? How heterogeneous are the health experiences that people have? In some sense, they are an expression of a health type. Okay? So the first question, and there were some very good papers this morning in the health session, is, well, we are economists, we need first measurement. Okay? So how do we measure health? First, this is going to be for the United States. But an important strength is that we are going to use the Health Retirement Study data, which is a very high-quality data set for the United States, but it also has all of the cousins in many countries, right, of which share, for instance, collects. So this is something that is very doable to do for these age groups for many countries, and I think that would be interesting to see the differences in health outcomes across countries. So we take people 52 and older, and the data are biennial, and we start in 96, given the nature of the data that we need. It doesn't start earlier, and it goes all the way to 2018, so that's a fairly long panel over which we can follow these 52-year-olds, and it is rich and high quality. So let me tell you really what is a big advantage of this data set that we use, other than the fact that it has very low attrition, it's super high quality. My co-author, Eric French, likes to say that there is one way out of this data set, and it is death. Okay? So these are a subset of many questions that measure health in the HRS. And this is a subset of questions that we have selected based on the medical literature and on the high quality of the data. Also, some variables in the HRS, like mental health, are measured for 1 or 2 years, right? And we want variables that we can measure from age 52 to 2018, okay? So the groupings are groupings that are typically used in the literature. For most of the talk, the groupings would be irrelevant, right, are just for you to categorize things. So ADLs are activity of daily living impairments. They really are impairments that affect your functioning, okay? For instance, having difficulty bathing, eating, dressing, walking 1 block, and crossing a room. The instrumental activity of daily living are just a little more sophisticated, right? But they are still severe impairments, grocery shopping, phone calls, and so on. There are other functional limitations. And we also use diagnosis. So, for instance, have you been diagnosed with high blood pressure, diabetes, and so on? Healthcare utilization is another manifestation of a health deficit that might or might not be present for a person. And we follow the medical literature, right? So this might not be super politically correct, but there is medical literature that classifies BMI larger than 30 and having smoked as addictive. But again, these labels don't matter for what we do. They are just for you to have an overview of the data. So what do we do with these health deficits? We want one unidimensional, simple measure of health. So, of course, you all know that health is latent, possibly multidimensional, okay? But we need to start simple. We want a unidimensional measure of health, and we follow the gerontology literature that has proposed this measure of frailty. And I will tell you in a second what frailty is. In addition to the fact that it has been proposed by the gerontology literature and validated, it also has advantages for us as economists, because what is the measure that we are interested in? We are interested in a measure that affects economic outcomes that are important to us. And frailty has been shown to be a very important, strong predictor of disability, nursing home entry, life expectancy, labor supply, a lot of economic outcomes that are important. And in another paper that we have, we show that this is also the case by race, ethnicity, and gender. Okay? So let me tell you what frailty is. You have seen these possible health deficits. Okay? They are typically coded as either present or not present. right? This is not an intensity of the density. It's either there or not there. So it's a dummy 1 or 0. And the Freity measure that gerontology has proposed is I'm having 35, right? In that table, there were 35 possible impairments. You sum all of the ones, and you divide it by 35, so it's a number between 0 and 1 that expresses the fraction of potential deficits that you have. Sometimes I will go back and forth because knowing how many deficits you have is intuitive, right? But it's a measure that is very well studied and very useful. And I also like that it has a quantitative interpretation, right? You know how many deficits you have as opposed, I will also use self-reported health later, but I think one of the advantages is that you can measure how sick people are in a maybe more clinical way. So we are going to have people who start in the data set age 52 to 53 because we want as long as of a lifetime from middle age and old age that we can have, and we follow them until 2018. So we have, I think, 12 waves of data because they are biennial. And we assign a Freity of 1 when people die, right? We want to study health dynamics and mortality together, right? And we see death as a manifestation of health. Now, you might be worried that there are a lot of accidents, right? And so assigning a Freity of 1 who people who die is picking up something that is not really related to health. You get hit by a drunk driver. Well, luckily for us, we have exit interviews. Remember, only one way out of this data set, death. But actually, they follow, you know, the family members or the person managing the estate. So even after death, you don't get out of the data set very quickly. And the exit interviews have mortality causes, right? And we have looked at those. And first of all, globally, only 4% of the sample die of non-health related issues. And then when I have my types, I will be able to show you that this distribution is constant across types, right? So accidents are not driving what we find. So now I want to extract some health types, and there were previous tools like Heckman and Singer or Keen and Wolpe, myself in another paper with other co-authors. We made we made functional forms assumptions, right, on the evolution of health and the distribution of types, and estimated these processes. And that's a perfectly valid, interesting method. We just want to do something different here, and I will try to motivate why it's a good complementary approach. So machine learning is becoming very popular in economics, and we are going to use a tool which is called clustering, and there is a large method, a large set of clustering methods. We are going to use in particular k-means clustering. So let me first tell you, I mean, many of you will be even more familiar than me about these methods, but we need to bring everyone up to speed. So the idea is that people are different. In my cases, they will be different in health trajectories, and I want to cluster health types according to people who have similar health experiences over a certain time period. So what happens at the end of the clustering is that observation in a cluster have similar health histories, and the clusters are chosen so that people in different clusters or health types, right? For me, a cluster and the health type is the same thing, are as different as possible. So what are the advantages? First of all, you know, clustering assigns a type to a person. There is no probabilistic assignment. It's very direct and very intuitive. A person has a given type, and it's non-parametric, right? So, you know, strength and weakness is there, but it's going to be a very flexible approach. Within the clustering methods, why k-means? Well, one of the co-authors, Elena Maresa, is also a co-author on the very influential paper by Stéphane Bonhomme and Thibault Lamadon that has used clustering for labor market outcomes. And they have shown, also from a methodological standpoint, they have identified, if you have a heterogeneity, what are the properties of discretizing this unobserved heterogeneity using a finite number of types through k-means. So this is the only method for which we actually have some methodological understanding of how the method represents heterogeneity. So for those who either don't remember or don't know what k-means clustering does, I will give you a very shallow overview because I also want to show you what are the economics that we learn from applying this method. Unlike other clustering methods, you need to decide how many types you want to have, which is k, right? And we will have criteria deciding how we pick those types, right? But you can think of clustering as indexed by the number of types that you pick. And conditional on the number of types, you are going to have a centroid for the cluster. And for the macro people, it's like the representative agent, right? It's a typical trajectory for people in each cluster. That's your centroid or your representative agent. And what you want to do is you pick everyone in this room and you want to assign everyone's health experiences to a certain cluster or health type. So that's the output of k-means. It's an assignment of a person to a certain cluster, and it's also the centroid of that cluster. How does that cluster representative agent look? And then all of the trajectories of the people in that cluster. So for those who like to sing a little bit of math rather than hearing words, this is what k-means does more precisely. HI is going to be a certain set of health history for person I. What is health at 52, 54, and so on. And then you want to minimize, so you have n people, you want to minimize the distance between person's high history and the representative agent or the centroid of the cluster. And that's the metric of distance that we use. And then you choose all possible centroids and assignments so that you minimize this distance. So that's what k-means clustering does. So let me be more precise. I only told you that we cluster histories. Well, first thing I've told you is that for every person I construct frailty, right? And I construct a measure of frailty, which is the fraction of deficits that the person has from age 52, either until death when it becomes 1, or until the sample ends, which is in 2018 when people are 74. So clustering is a non-parametric method, so you always need to worry about overfitting. Right? So what we are going to do is we are going to split lives into a clustering period that goes from age 52 to 60 and the validation period, right? So which goes from 60 to 74. So I'm going to extract clusters on the first part of life, and then I'm going to see how they predict future events with the idea of seeing, is this a random realization of luck, or is the type really something inherent to the person that helps predict the future? Okay? So that's why we choose this clustering period, and we can talk more about this. So more precisely, the HI that you have seen, the person health trajectory, is frailty at 52, 54, 56, 58, and 60. Okay? So these are the histories that we cluster to determine what a person's type is. So intuitively, a person has a type that expresses themselves into an initial frailty, but a trajectory. Right? There might be people who start out very sick, but they sit there. And in contrast, there might be people who start out very healthy and they deteriorate very quickly. Okay? So a cluster will group, given what we do, people who have similar initial health and similar trajectories during the clustering period. So now, let's go back to the important question of how we decide how many health types we have. What is K? Well, so first of all, in the second bullet point, machine learning has criteria. Right? For instance, you want to check what fraction of the variance of the observation your clusters explain, right? This is the elbow method. And then when the fraction of the variance is becoming flat, right, the variance unexplained decreases with the types, right? When it starts becoming flat, right, this is an heuristic method, you don't want to increase the number of types anymore. The silhouette has a similar criteria. But we also want a more economic criteria, because in the end we are economists. And so what we want to do is to pick the number of types so that when we look at the predictive power of types for future health and mortality, increasing the number of types doesn't improve your predictive power within the sample. Okay? So, however, you need to be careful. You don't want to cluster and perform the regression on the same sample even between the age of 52 and 60, right? So we do what is called a tenfold validation. So let's say the training set is all of your data between 52 and 60, right? You split the sample in 10, right? You estimate the clustering on the first 90, and you validate on the other one that you didn't test on, and then you rotate with all of your temps, right? This is another method to determine how many types we have. So we use both machine learning and this economic forecasting method within the clustering period, but out of different people, right? So as you can see, when you have a parametric method, you need to make parametric assumptions, but when you have a non-parametric method, you need to be really careful about overfitting, because it's not as easy to determine, you need to work to make sure that you are doing things all right. Okay, so at the end of this, we obtain 5 health types, but you wonder, well, yes, you did some cross-validation within the sample, but are these really health types? Well, first of all, within this period between 52 and 60, my 5 health types explain 84% of the variation in health outcomes. That's the first piece of information that you might care about. And then I want to go back to seeing if these types predict outcomes after age 60, right? And do they predict, in particular, future frailty and mortality? So something that is going to be interesting is that some people die before 60, right? So this is going to be a stringent test on the remaining of the survival, and we can talk more about this. So what we do is we predict future frailty, or the probability of dying, as a logit, the last one. Conditional education, so we don't only use health types, we use also the observables that people traditionally use. So education, race, gender, HRS score, marital status, and polynomial in age, and initial frailty, and SRHS is self-reported health status, right? They ask people, how do you rate your health? Excellent, very good, good, fair, and poor, and it's another measure that has been shown to be important to explain economic outcomes, so we use that one too, right? So we are trying to bias ourselves toward, we are trying to make it hard for types to do the job, right? So this is not a cheap validation, I don't think. So what do we find? So in the first 4 columns, this is predicting frailty next wave after age 60. And you can see that first, if we use this rich set of controls that you have seen in the previous slide, education, race, and gender, and blah, 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 we only explain 12% of the variation in frailty in the future wave, right? And remember that in many structural models, we spend a lot of energy modeling this amount of heterogeneity, and I have done it with my co-authors, who luckily are not here. But, we all know that women live longer, but do we really need to model gender, or maybe do we need to model health types? That's one of the things I want to understand by the end. What happens if instead we have both all of those controls and health types, right? All of a sudden, your ability to predict future health and mortality goes up to almost 60%. And interestingly, when you have initial health, you already go a lot of the way, right? You go to 50%, but not to 56%, because these trajectories per se are more informative than just initial health. I mean, the initial health doesn't determine all of your future experiences. The history is much more powerful. And the other thing that you can see is that if we have all of this, we get to 60%. But the bottom line is that, yes, these are health types in the sense that not only they explain health variation, history variations in the clustering period, but they also help predict important economic future outcomes. And although initial health is important, types are more explanatory, and it makes sense, right? We already discussed this potential heterogeneity in trajectories. So let me wrap up what we learned about question 1, right? Because as you will see, there are many regressions and many moving pieces. So I think we do uncover evidence that says that there are health types, and I haven't shown you all of the details, but we find that there are 5 of them. And they capture a lot of variation in health histories during the clustering period, and they predict future health and mortality after the clustering period. So let's now look at what these types are and what we learn about people inequality in health from this clustering. Okay, so these are, you have age from age 52 to 74, all the potential sample we have for this cohort, and then you have our measure of frailty on the vertical axis. We order the types, this is just a label, depending on their average frailty during the clustering period. Okay? So type 1, notice here, frailty, low frailty, good, right? Because frailty is the fraction of health impairments that you have, right? So it goes the opposite direction that you're thinking, good health, higher health, good, right? Here, higher frailty, bad. So type 1 are the people who have the lowest health impairments, and they are 57% of the population. And what you can see is that the red line is the clustering period. They are characterized by a slow trajectory in health worsening. Type 2 comprises 28% of the population, right? And these are average trajectories by type. And they also decline. Interestingly, you see that type 3 starts out like types 2, but then declines very fast. And it's a small fraction, it's 2%, but you know, those people might really matter for welfare or for inequality or for policy evaluation. So just because a group is small, you don't want to ignore it. Partly because you're going to attribute their trajectories on average to some of the other types if you ignore this type of heterogeneity. Then you have other two groups, 4 and 5, which also start similar to each other, but then 4 slowly accumulates health impairments, while 5 also jumps. So here, there is something important. I told you that when people die, we code their frailty as 1, and we keep them in, right? So this includes deaths and frailty conditional on death, and I said, now I want to unpack this behavior. How much is death, and how much is fast worsening of health? So death is important, right? And so here I have age, and I have the fraction dead, right? And remember, the red line is always my clustering period. So what does the cluster do, right? It clusters type 1, 2, and 4 as almost no one dies before age 60, right? These are people that have initial health or frailty of different levels, and they don't deteriorate fast. Types 3 and 4 are groups with high early mortality. Okay? But is this all there is, or is there something else? Okay? It's not all there is. This is frailty for the survivors, right? So here I'm kicking out the ones when people die, so you can see what happens to people in each group conditional on being alive. So of course, for types 1, 2, and 4, in the clustering period, these lines overlap because nobody dies in those graphs. But groups 3 and 5, you can see that not only those are a group in which there is an early death, but they are also groups in which there is a fast increase in frailty for the survivors. So those groups are characterized by both fast deterioration and early death, right? So you might worry that I'm picking up accidents, right? So people in groups 3 and 5 are people who are hit by a car or by a drunk driver. And so that is also where we looked at cause of death, right? So, and you can have cancer, heart, other health-related or non-health-related, right? And you can see there are types on the rows, and you can see the non-health related is marginally higher for group 3, but nothing really stands out, right? So that's why I think that this death is also a manifestation of health. What these types are picking up are fast deterioration and death that is related to health reasons, not to accidents. So what did we learn about these health types so far? At age 52, health is already very unequally distributed, and essentially you can find 3 initial health types, right? You remember, that's what I mean, right? Because types 2 and 3, they look identical, very close at age 52, and types 4 and 5 also, they look very similar. So from the standpoint of age 52, type 1 has 2 health deficits. Common health deficits are being overweight at this age, having ever smoked, and high blood pressure, right? These are typical, right? I mean, type 1, remember 57 of the observation, and you might think it's either good or bad, right? Personally, I think that the fact that people at age 52 already have 2 health deficits on average, the healthiest type, is bad, right? But it depends if you are a half full or half empty kind of person. I think it's sad, but anyway. Types 2 and 3, they already have 6 health deficits. And you remember that table, a health deficit is a big deal. It's not a small thing like your toenail is hurting, right? And types 4 and 5, already at age 52, they have 14 health deficits, right? That's why I think that talking about health deficits is sometimes interesting, not only using frailty. But after age 52, they have heterogeneous health trajectories. Most people have a slow deterioration, but there are some people that experience fast deterioration and death. So we label these health types. So type 1 are vigorous and resilient, right? Types 2 and 3, they start in fair health, but some of them are resilient and some of them are vulnerable in the sense that they deteriorate fast. And types 4 and 5, they start frail, but even among the frail people, most of them are going to hang in there, and then there is instead a fraction of frail people who has very fast deterioration and death. So now, can this be captured by observables, right? Maybe observables that people have been using, they do all of the work, and we don't need to go through clustering or thinking about health types. Well, sadly, or not sadly for us, no. So I get worried because when I timed myself, I was so fast, and now Jaap tells me that I have 10 minutes. Anyway, so you might think that being a woman or being black or being more educated, they explain a lot of these types. In reality, there are some correlations, but they are not, I don't know if you can say that the correlation is linear, but they don't add up to a full story. For instance, let's look at the fraction of women. They are 63% of our sample. They are less likely to be of type 1, the healthiest and resilient. They are more likely to be of type 2 and 4, right? We know from previous literature that women have more impairments, but they are less likely to die fast, okay? And to pick another one, let's look at education. Yes, more educated people with 13.6 years of education are more likely of being of type 1. But when you look, for instance, at whether they are type 2, who are not so healthy, but they stay in there, and type 3, who are similar, but then they die fast, you actually see that the type 3 has, if anything, slightly more education than type 2, okay? So there are some correlations. We can look at other things, like healthy behaviors or health insurance. And the one that is interesting and goes in more the direction that you would expect, I would say the only one that is consistently what you could expect is having ever smoked. For instance, 56% have ever smoked. And what you can see is that the fraction is increasing in bad health, and it's consistently higher for similar people who die faster. Okay? So how do we I mean, these are interesting, but let's try for something a little more cohesive, right? So what we can do is we can run a multinomial logistic regression of a health type, on a lot of observables and see how much of health types can we explain through these observables. Right? That's a way to determine how much observed heterogeneity can help explain these health trajectories. So in the first column, you have that include demographics. I flashed the table fast. Health behaviors like exercising and I forgot what the other one is because I'm stressing about time, and health insurance. And what you can see is that the pseudo R-squared of observables on health explanatory power of health types is very low. Already, when you only use initial frailty, well, you get to a much higher explanatory power, and then when you use everything, you get to about 0.45. So the interesting thing is that when you add all of the observables, you do a little better than just initial frailty, but not a lot, right? So all of these structural models like mine, so worried, we have a woman, is she married, is she high permanent income, is she high education? Well, maybe we could have been parsimonious and have extracted the health type and then condition on the health type. It doesn't really matter what the other characteristics are. And this is a provocative maybe, right? It's not what this paper will be able to tell you. It's a start. So what is the answer to question 3? The answer to question 3 is that this is largely an observed heterogeneity and that these health types are a parsimonious way of representing all of this heterogeneity in health and mortality. Now, so what, right? When we got here, I told the co-authors, we are at the so what stage. Why should people care? So what if we ignore these health types? Okay, so now I have constructed my frailty and my health types, and I want to study how another important measure of health, which is self-reported health, evolves over age 52 to death or end of the sample. And I want to study the influence of types. So this is a different health measure they have used before. Okay, so this is another validation in other respects. So I'm going to run a multinomial logic of being in very good, excellent, very good, good, fair, poor, or dead health on a rich set of observables, which is the state-of-the-art observables that are used in many models, including structural ones, and health types. So what am I going to do? I'm then going to compare the outcomes of the model without health types for mortality and future health, and the model with health types, right? So the exercise is going to be the following. I know what health type Raffaella and Jaap are, right? And I keep track of who they are because K-means gave me the truth. But first I'm going to give Jaap and Raffaella the traditional Markov 1 model of health dynamics with a lot of observables. Okay? And I'm going to ask, they are going to be of type X and type Y, how does the model forecast what is going to happen? And how does the model with types and all observable does? Okay? So this is the fraction of people who are alive. The solid is the data, and the dashed is the model with health types, right? Remember, I know what health types they are, but when I apply the model with health types, you see that the model does a very good job of predicting death during the clustering period and after using this self-reported measure. What about the model without health types? See those lines all clustered up there? Right? That is the Markov 1 model with a huge, maybe huge, you can always find more, but with the state-of-the-art set of observables that we use, at least in structural models, and you can see to what extent all of those observables explain these heterogeneity in health paths. Well, you might think, well, there is death. Death is kind of extreme. How about people saying that they are in excellent, very good or good health? I show you the fraction of people say I am in at least good health. Right? So, and remember, I know what the types are. I just apply the traditional state-of-the-art model as opposed to the types model. So on the left, that model with types captures very well the deterioration of health conditional on survival by type. Look at the model without health types. Well, it predicts a ton of mean reversion because it's not keeping track of the fact that the rate at which people health deteriorates, right, which is what clustering gives you, is a very important predictor of future outcomes. Okay? So the answer to question 4 is that you miss a big deal by not having health types by health type. So now, I'm also a macro person, although sometimes it doesn't really show. Let's say that we want to have or a public finance question, right? This morning we were talking about Social Security, who really benefits from increasing Social Security payments, right? So if you want to use this health process in a parsimonious way, can we ignore, for the purposes of health or mortality, gender, marital status, education, and all of these things? Okay, so I have the same regression you have seen before, future self-reported health and mortality. First column, we have observables, it's a Markov 1, so previous health and age. You have a pseudo R-square of 0.26. Look at what if I drop all observables, gender, education, marital status, I only have the health types, and age. I explain more, right? So let me conclude. We propose a new method to evaluate health outcomes that are based on health trajectories and is non-parametric. We find very heterogeneous health types that also predict the future. And they are unobservable, but easily, well, I mean, never is ever easy in life, but you can use k-means and attribute types. And I showed you that you really miss on health and mortality trajectory. So now this is a plenary talk. I want one more slide to tell you what would be interesting to do moving forward. So first of all, I think the first step is to have a more realistic model of health trajectories when we evaluate what people do as a result of bad health, how we should reform Social Security, how we should change health insurance. And I think that this is important not only to understand the health inequality across people, but also to better evaluate these policies that we use these structural models to generate policy predictions and to compute welfare. More broadly, I picked a certain clustering period, but we didn't, I mean, how many years should you cluster and how many years should you validate? That is an important question operationally, but also economically, right? Do people know their health type, right? So I think that people know, in many cases, if people are not adopted, they know their family background, they observe their parent outcomes and so on. So they have some signal. And then the question becomes, how many periods of their health do they need to really learn about their health type, right? And in some sense, the clustering period is related also to how long people need to learn their health. I think this is a fascinating question over which we do nothing. We start at age 52. What happens earlier on in life, right? It's interesting to also expand the analysis to younger periods. But then the big important thing is, are these health types, do they help explaining education, marriage, fertility, medical expenses, retirement, right? I have only shown you that they help explain health and mortality, which is important. But, if you find that they have no relationship with other important aspects, maybe people don't know them or maybe other things are going on. And then I think it's very important to think about why do we have these health types? Where do they come from and how are they formed?
Can you hear me? Yes. Thanks a lot for this great talk. We have some time for questions, and there's someone in the room who will help you speak up. Where is the mic? There's someone here who wants to ask a question. Thank you.
Thank you very much for that. So on the deficits, are all deficits equal in your health type construction? I've got 2 of them. That makes me look good, but actually the 2 I've got are pretty bad, I think. So I was wondering.
Yeah, thank you for this great question. That's something I wanted to mention, and it's important. So usually people are surprised. Why is frailty such a good measure? And why are the gerontologists who are supposed to help us measure frailty pushing such a simple measure? I have two answers to this. The first one is that there is a lot of comorbidity, right? It's very rare that you have one condition and it's extremely severe, right? If you are in bad health, comorbidity means that, say, you have cancer and then, either because of the cancer or the therapy that you have to go through cancer, you develop other impairments, right? So I think this is an important intuition of how the comorbidity, meaning that diseases cluster, right? You might start with one condition, but very quickly you have more than one, is an important reason why clustering is such a good measure. What I can tell you is that we have also looked at whether, for instance, when we were trying to explain health types, in the logistic regression of health types, we have included these sub-components of frailty to try to say, well, maybe types 3 are people with cancer, right? And we find no such relationship, right? And other people have tried to find of different ways of adding these principal components or factor analysis. Poterba had an older paper on this, and they find that frailty is just a very good indicator, and I think the intuition is this comorbidity. Now, what I think would be interesting to do is we have ways like lasso regressions of figuring out which combination of regressors help to predict a certain outcome. Right? So I think it actually would be interesting to say which measure of health best predict future health or mortality or disability or nursing home entry. I think that would be an interesting exercise to see, can we find a measure, what is the best predictor, for instance, using lasso, but there might be other machine learning methods, that predicts a certain outcome, and what is that health measure telling us? I think that would be, I always wanted to do it, we never had the time.
Other questions? Over there. Can you raise your hand again? Thank you.
Yeah, thank you for the very interesting talk. So one thing I was wondering about, since you suggested that you could kind of replace, let's say, more traditional Markov type health processes with your health types, but the health types are constant, if I understand correctly. So you kind of eliminate any health risk, and if you are, say, interested in implications for labor supply or retirement, that is kind of probably also a function of your health risk. I was just wondering how you think about that if you don't have any health risk anymore in the model.
Yeah, that is just because I was not very clear and I rushed through the end, but the suggestion is not to replace the Markov ones with processes with health types, is to augment the Markov ones with health types. And and there you might wonder, well, how flexible should this specification be? Should your previous health be interacted with your health type, for instance? And what we find is just that a Markov one with a Markov one with the addition of health types. That's what you see here, right? I just went through this very quickly. So the suggestion is to add the health type to the traditional Markov one, and perhaps just for the purposes of understanding health and mortality, we don't need to model gender, right? So why do we model gender or education? In some cases, it's because women live longer, right? Or married people live longer. But if you have a health type that already summarizes all of this information, at least as of age 52, you don't need to look at a number of many other variables that only indirectly capture what you want to use.
Maybe one last question over here.
Is it all one-way traffic, so you're only going to get worse and you're only going to stay with some frailty. There's several things on that list that, in theory, with the right treatment package, the right set of exercises and so on, you can work your way out of. I was just wondering how much this is treated as a fixed condition that people can't escape from.
So I'm going to use your question as an excuse to show these beautiful heat maps. So thank you. So a heat map, right? So if maybe you were asking about conditions, what I'm going to show you is to what extent people recover or don't recover depending on type and how they evolve during the clustering period. So this is the vigorous resilient, the type 1. And the whiter, right, the graph starts completely white. The whiter it is, it means you start with no condition and you continue with no condition. And the darker it is, the worse your health is, right? So, for instance, see in the correspondence of the point 29, there was someone who started with some impairment, right? Maybe they couldn't walk across the room because they had surgery, they had hip surgery, and so there was a period, or maybe even 2 or 4 years. But there are some recoveries, right? Many of the trajectories are about deterioration, but you have some switches. And what is interesting, right, you can look at the heat maps by types. And what you can see is that, again, there are some recoveries, and they tend to be perhaps more frequent when the length of the illness is not very long, right? It's rare to see someone having a lot of black and then recovering. And then you see that the general tendency tends to, right? And here, this is interesting. This is for people of type 3. Look at, actually, there was someone, I see that black line, who really was impaired, right? And maybe it would be interesting to go more in a micro way and say, okay, so we now know what these trajectories are. Let's look at the conditions of people who recover and who they are. I think that's an interesting question. So I think this is just a partial answer to your question. We know, right? And this is a group 4. These are frail, but they hang in there, right? And this is a manifestation. Most of them have a slow deterioration and some die, but most tend to die later on. And these are your type 5s, right? And yeah. So thank you for this question. I like the heat maps, so.
All right, I'm afraid we have to wrap up. So once more, please let us thank Marie-Christina.